I am Optimus Prime. No, I'm actually not. I'm Mr. Pouts. But hey, we are gonna work with transformations, just like Optimus Prime transforms from a semi into a transformer robot. Anyway, if you don't know what I'm talking about, just ignore me. We're here going through lesson 3, session 2. I'm going to call it lesson 3B. We are continuing to work on performing sequences of rigid transformations. So we have 2 learning targets. This is the one that's kind of involved in all of our lessons, or all of our sessions for this lesson, to understand that a 2-dimensional figure is congruent, or the same, to another if the second can be obtained from the first by a sequence of rotations, reflections, or translations. In other words, if you can take any rigid transformations to get from one shape to another, and they go right on top of each other, then they're the same, they're congruent. So we're going to focus today on this one that's in bold. Be able to perform a sequence of 2 or more rigid transformations given any figure on a graph. So let's start with the problem of the day here, and we're going to read through and we're going to kind of break it down, and then I'm going to have you try it. So it says, and follow along here, please. It says Kimani and Jake each perform the same 2 transformations on figure T. So this is our original figure T, but not in the same order. Kimani's sequence is a reflection across the y-axis, followed by a translation 4 units to the left. Whereas Jake does a translation 4 units to the left, and then follows it up by a reflection across the y-axis. So I want you guys to think about how you could say this in your own words, how you could break it down and kind of describe it a different way. I would say they're both doing a transformation on a graph, just in a different order. Actually, a sequence, so 2 different transformations on a graph, just in a different order. So let's read it through one more time. Kimani and Jake each perform the same 2 transformations on figure T, but not in the same order. Kimani's sequence, a reflection across the y-axis. Remember, the y-axis goes up and down, so it's across that. It should jump over it. And followed by a translation 4 units to the left. Jake's sequence is a translation 4 units to the left, and then a reflection across the y-axis. The question we want to answer here, ultimately, after we're done, is, will both sequences map figure T onto the same final image, and I want to add in the same spot? All right, that's what the question I want you to think about as we're starting to do this. So why don't you go ahead and try it on your own and see if it works out. So, question to think about. How did you decide whether both sequences map figure T onto the same image? What was the strategy you used? Did you graph it? Did you just make an assumption? What'd you do? Let's break it down here for you. If you look, this is Kimani. Kimani took figure T and reflected it across the y-axis first. That means it flips over the y-axis. It's the same number of units away. It's just all reversed. For instance, this is 1, 2, 3, 4, 5 units away, and then it should be 1, 2, 3, 4, 5 on the other side. But everything is reversed. And you end up at figure W. And then she took, so number 1 was the reflection over y-axis. And then number 2 was a translation 4 to the left. And she ended up with this as the final figure, figure X. Now, Jake did it in a different order. Jake first translated it 4 to the left, so it's just the whole shape moved 4 to the left. Each individual point went 1, 2, 3, 4 to the left. That was the first thing that Jake did. And then number 2 was a reflection across the y-axis. And notice, this is where it ended up. Is that anywhere close to where Kamani's ended up? It doesn't look like it. So I guess the order in which you do a sequence of transformations does matter if you want it to end up in the same spot. They're in the same orientation, they're just not in the same spot. So let's just take a look. Let's just take a look at each of the individual vertices that was done in each sequence. So this is Kamani, and this is in your book here. The original coordinates were the same in both. Now, when you reflect across the y-axis, maybe you remember that just changes the x value. So you could rewrite it like -5, -2 instead of +5, -2, and they all just switch. So it's moved over there. But then when you move it farther to the left, this x value is going to change even more. But you notice the y values don't change at all the whole time. It's going to go farther to the left. It's going to go down 4. Whereas if we're looking at Jake's, he translated it first, so it first went down 4, down 4, down 4, but the y values all stayed the same. And then you flip the x value to the opposite. And you'll notice the final results are significantly different. They're actually, looks like they're 8 units different, 8 spots away from each other in the end. So let's just talk about that a little bit. If you look on page 51 in your book, we have some questions about this situation. So first question is the one we kind of want to answer. Did both sequences map figure T onto the same image? Well, our answer is no. And how did the picture and model each show this? It's visual on the graph. You can see it on the graph. But we can also see it just with the coordinates based on what we talked. Now, it says, how do you know that both images are congruent to the original figure? Well, you can look at it. I would say, number 1, look at it. Number 2, you can measure it. Whoops. Second thing I would say is you can measure it or count. But number 3, and the most important thing that we talked about in last section, is they are all rigid transformations. A reflection and a translation, or a translation and a reflection, they don't change size. We've established that. So they're all rigid transformations. All right, number 2, new example for you. Let's see if what this does. It says A, translate figure T 3 units to the left, and then reflect it across the x-axis and find the final image. So I'd like you to stop and try this. And then we're going to try it in the reverse order and see if it's in the same spot. So I'm going to do this one the first one in red, and the second one in green. And I'd like you to pause again and try. All right, I go 3 to the left. So I'm actually going to take each individual point, go 3 to the left. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And I've got my shape right here. Same shape. Just move to the left 3 spots, and then I want to reflect it across the y-axis. So remember, when I reflect it across the x-axis, sorry, that's right here. It's got to go over the x-axis. Same distance, so 1 away here, it should be 1 away here. 2 away here, it should be 2 away here, and so on. So there, we got 4 away, and then we've got 7 up over here. So there's my final image. Now we're going to do the same thing with green. It says, but in reverse order. So let's reflect it first. So 1, 2, this is 1 away, 2 away, 7 away up over here, and then 4 away from the line right here. So there's my shape reflected. So it's reverse, reflected across. And then we want to move it, let's see, what is it? 4 to the left? Sorry, 3 to the left. Oh, 1, 2, 3, 1, 2, 3, 1, 2, 3. And what do you notice about our shape? It ends up in the same place. So do both sequences map it onto the same image? How do you know? Yes, because we graphed it. So in this case, when it's a translation and a reflection, it worked in the same order, or it worked in different orders, whereas the last one, it didn't work in different orders. Isn't that interesting? So number 3 says, what can be different about a figure and any of its images after a sequence of translations, reflections, and rotations? And what always stays the same? So we've talked about this so much. What could be different? That's the location and or orientation. Remember, it could turn or flip. How you see it could be different. But what's the same is always the size and the shape, no matter what you do to it. So I'm going to leave you with this for right now. I'd like you to think about all the models and strategies we did in this lesson. Describe how one of them helped you better understand how to perform sequences of transformations. What helped you here? Was it looking at the coordinates? Was it looking at the graphs? Was it talking about it? But what helped you understand a little bit better sequences of transformations? That's what I'm going to leave you with for today. Thinking about our goals of mainly performing a sequence of 2 or more rigid transformations given a figure on a graph. That's lesson 3B. Have an awesome rest of your day.